All right, guys.
Okay, we gotta work on that. Okay, let's just start right now. Let's just go.
Hello and welcome to the OverVolted podcast. Today we are joined by Jim.
All right, guys.
And Matthew.
All right, guys.
And Aurelian.
All right, guys.
I don't even know which one of those was the worst. I think Matthew sounded a little bit like Dick Van Dyke.
Isn't that what you said last time, Kirk? Last time we tried to do that?
No, it was me that said it last time as well.
Okay.
Yeah,
so Jim's was the worst of all of them. I'll just put it out there.
Yeah, I was the worst at my own accent.
You're just not like the 2016 Jim.
I am not like the 2016 Jim. That is true, yeah. When I look through some of my old videos, I'm not doing this because I'm a narcissist, by the way, but I sometimes get an email even from those old Elite videos or something like my HOTAS X review. That's an interesting one to listen to. And just like an email from coming through a comment on YouTube, because I get every comment emailed to me just so I can respond instantly. And obviously it plays the video and my accent back in those days.
We should
really
reach back into the
else.
video archives and grab some snippets from that.
Yeah, that's a good idea, actually, yeah. Anyway, let's continue with the podcast. I think we're going to talk about tech today, are we not?
Yeah,
Maybe.
we actually have the big Apple WWDC stuff, particularly Big Sur. That'll be interesting to talk about. So we're no longer on macOS 10. We have another bigger and better, basically Navi chip. We have some code leak for that. We have Windows 10 GPU scaling, as well as some talk about the transition with Big Sur from Intel CPUs over to, we have the Apple ARM CPUs now. We got the Slidedeck, nice infamous Intel Slidedeck that we'll talk about some. And we might have something a little later at the end about AMD. So let's go ahead and get started here with macOS 11.
So, yeah. Well, the important thing for me, I don't really care about Macs at all. I don't own any Apple products, although I do like the iPad. So I'm not really fussy about what's happening in the world of Apple in all that honesty. I'm a PC guy, always will be. But Hardware Leaks, better known as Rogue Game, has discovered a AMD codename of Navi31 and also MI200. Was MI200 a new one, or is this?
I think that's been rumored. I could be wrong.
Right. Well, Navi31 is for sure a new one.
Yes, that's new.
Anybody could have guessed that this was going to be a code name, but it's Rogue Game, and we know that he's like 100% legit. And it was found in, what was it, drivers for the new?
Yeah.
Yeah, the new Big Sur, I think, Big Sur macOS 11. Here's what I found interesting about this. And there's a bunch of added support for Navi22 and Navi23. Yeah. In the drivers, and as I said, Navi31 also referenced quite a lot of times, in fact, and also the MI100 and 200 and Cezanne. Now, what I wondered about this was in previous releases, like Navi 20, even the first one, was it not Linux that we first saw these code names being outed in? Yeah,
it's usually Linux. Yes,
it is usually Linux, isn't it? But now, for some reason, Apple. So I just wondered if there was maybe something in that as well. I mean, I think the AMD or Radeon Technologies Group, they are definitely becoming less PC focused, less PC centric, and more towards the consoles, more towards Apple. Yeah. I mean, we keep thinking there's a lot of money there at Apple, but I don't really see AMD making a fortune at Apple. Don't appear to be. I mean, there's nothing that I've seen to suggest. Unlike Intel, whose like Apple business is like 5%. However, that's CPUs, and it should be quite a lot. But then again, if you're having an an Intel CPU in a Mac, you're generally going to have an AMD graphics card there. So it just makes me wonder. We'll get to that point a bit later, though. But I mean, that was pretty much it for this leak. Navi31 mentioned.
But there is also references to Van Gogh and Cezanne, and as we know, Apple has transitioned to ARM off of Windows. But Van Gogh and Cezanne are APUs, which is weird.
Well, Van Gogh comes after Cezanne's, is it not?
No,
Was it
no, Van
Gogh
Gogh is the one that should come this year, and Cezanne
Right.
is the one after next. But I believe
yeah.
Cezanne is the one that's like the more CPU focused, less GPU focused. Van Gogh's the opposite.
What gave you that impression?
Well, that's just like the popular theory is that Van Gogh's sort of a new kind of APU. Cezanne is the Renoir successor, and I think the Van Gogh successor is supposed to be Rembrandt.
Well, there was some more interesting news based on this over at Igor's lab again.
Yeah.
And he reckoned that based on something he was told by Rajas a few years ago, 5 years ago actually, he was told by Raja that talking about MCM, multi-chip modules, or MCP, multi-chip packages. And he asked him a question like if something applied to GPUs as well about this multi-chip stuff. And Raja responded with both. And now Igor reckons that this could be the start, AMD's start of using chiplet GPUs in some fashion, in some way. Or it could just be similar to like what NVIDIA's got, where he reckons there are several chips mounted on like one VGA.
Yeah.
And he speculates they think interposers would probably work as well. I mean, if they're doing something like that, and if interposers are required, that is still a lot of money. You're looking data center first, or maybe Apple first, because they can afford this sort of fancy stuff, put it that way. It's pretty interesting to see that even though AMD are not getting a lot of money out of Apple, or it doesn't appear to be the case, that they're making like a fortune.
Yeah.
They're getting something out of it regarding R&D. Because we know that the last Navi stuff that we heard about for Apple, did that not have both HBM and GDDR controllers or something?
Yeah,
Or
Navi has both, doesn't it?
But it was only the Apple one. Was it
Yes.
Navi 12?
Yeah, Navi 12.
Only Apple actually got the HBM that we've seen so far. And that was also based on last generation.
Yes.
Pretty weird, actually. That's kind of strange. I mean, I don't know how much Apple's paying for that, but...
And Navi 12 was rumored for a very long time.
Yeah.
Like I remember writing an article or two about it, like either early this year, like 6 months ago, or like late last year.
Navi 12 was one of the first rumoured products, actually, and we were all kind of surprised when it came out as Navi 14. Because it was found, like the codename Navi 12 was found in leaks, I think.
Wait, I think I might have even written a Navi 12 article when I wrote at Tom's.
You probably did.
Yeah.
And I think I talked about it a few times in videos as well. But
So-
Navi 12 arrived and it was an Apple product with HBM, yeah, so it makes you wonder, they're definitely getting something.
But maybe the
out of
reason,
that. Sorry, continue, Aurelian.
maybe the reason the Apple had the HBM is because generally speaking, the Apple products do tend to cost more. So then the cost of having HBM there is kind of covered by the fact that the product is costing more compared to if you put it inside a GPU that has to be within a certain price margin. Then.
Yeah, and
maybe that's the one reason. I don't know.
You do also get the power benefits from that, and also form factor. I mean, it really helps the form factor as well because you don't have the DDR chips required. But yeah, that was pretty much it for this one. Navi 31, we could have expected it was coming. The fact that Rogaine, well, he's found it and all this, you can take it as it's something that's definitely coming. Whether or not it's going to be multi-chip, we're just going to have to wait and see about that one, I think.
Maybe they just have a traversal coprocessor.
Yeah, you never know. I noticed that Igor had a bit of a go at Celso over at Cortex about that one. He had a good laugh at that one, he said. It was highly speculative, but we'll wait and see on that one as well.
Of course.
He got the ARM thing right with Apple. He called that.
Yeah.
Like a year ago.
Well, I think a lot of the writing was on the wall when they started comparing their iPhone performance to laptops and Ultrabooks. You knew that they were going to start saying, well, why don't we just start putting our ARM chips in our at least low-end equipment? I wasn't expecting them to do across the board or anything, but that might be why we're seeing the AMD APUs. is they might reserve those for the more high-end performance-oriented workstation type laptops and desktops.
Yeah, maybe. That would make sense.
And we will, of course, be talking about that a little bit later in the podcast.
Yes. So,
Yes.
Matthew, if you want to talk about the Windows GPU scheduling that you did some benchmarking on.
Yeah, so it was June 24th, and NVIDIA released their new driver, and it included a feature called GPU scheduling, and I decided to check it out, like on a whim, basically. I was actually updating my G14 for like an unrelated reason. I noticed the new driver was there. And this GPU scheduling feature had already been added to Windows, but it required GPU vendor support. So I benchmarked it on my G14, which has the Turing-based RTX 2060 Max-Q. Not particularly fast GPU, but
Not to
good
be
enough.
confused with a 2060.
Yes. Yeah.
Which Intel might have done at some point last week.
Anyway, we're getting ahead of ourselves. Anyways, so I benchmarked it on the 24th. I got this out within like 2-3 hours. It was a really quick benchmark, and I'm very proud of that. And all I benchmarked was Civ 6, Grand Theft Auto 5, Hitman 2, and Witcher 3. And I didn't really notice a difference in GTA 5 or Civ 6, but in Hitman 2 and Witcher 3, there was quite a big difference. It was only like mid to high single digits for these two games, except for Witcher 3 in the 99th percentile. You can see that it goes up a lot in Witcher 3 on the 99th percentile. That's a 13% increase in performance there, which is really impressive for just turning on a feature.
What about your testing methodology? Can you just give an explanation of what you're doing regarding your testing?
Oh, well, I turned on the G14. I have to turn off everything in the background. The difference, of course, is whether or not GPU scheduling is on and off.
Yeah.
And everything was updated like the day I ran the first test. And then nothing else was updated the day I ran the second test, but 4 more games.
Yeah.
And also, one thing, I use 99th percentile and not 1% low, because 1% low is garbage and you shouldn't do it. Because what 99th percentile does is that it basically takes the value of the frame rate that would make it as good as 99% of the best frames, or another way to put it, better than the worst 1%. The reason why you don't use 1% low in a good review is because 1% low is actually where you take the bottom 1% of the frames and then you average it, which is not good because the 1% worst is very inconsistent. You have to run many, many tests in order to get usable data, whereas I only run it 3 times usually, and then I take the median result.
So you basically run 3 benchmarks of each sequence.
Yeah,
how long a sequence would you say it was?
It depends on the game. Some games are really awful and like autosave. So for example, Metro Exodus, I could only benchmark that for like 1 minute at a time, or even less, because then I would go into another area and it would instantly save the game, and I wouldn't be able to keep benchmarking it over and over again. Now I almost always
1 minute's pretty good, I think. I mean, a minute of gameplay, I think that's fine. If you're doing that 3 times in a row, that's actually pretty good.
It's not as consistent as I would have liked. It was consistent enough, but it wasn't super consistent. A longer run means more consistency. Or if
Sorry, continue. Well, what I was going to say is, like, when I was benchmarking, I would do 3 runs as well. But if any one of them was like out by more than 2%, I would run it again and again. I could sometimes end up doing like 5, and you would see one that was just a little bit wrong, but the other 4 were really close.
Yeah.
And 2% or more, and it was out for me. I wouldn't accept that result until I got multiples that were all within 2%, and in most cases less than 1.5%. In the average frame rate.
Every now and then I get a result that's quite a bit off. Not like more than 10%, but usually like somewhere between 5 and 10%. And
that's
as long as I get
then.
as long as I get 2 results that are pretty much the same, I'm okay with that.
Yeah.
Well, some games like Total War 3 Kingdoms, where it's I use like a historical battle. I don't play it the whole way anymore. Yeah. But you'll naturally just get different results because you play it slightly differently.
It's also going to be a random benchmark, that one, though, because the
not that
battles can
random.
go
It's
either way.
actually not that random. It's pretty
not?
consistent. No,
That's
no.
interesting because
It usually goes the same way, more or less.
yeah,
Okay.
that's pretty
Anyways,
interesting. Yeah, continue.
so the methodology basically, I almost always use in-game gameplay instead of like an in-game benchmark. Very rarely do I do that. I use the 99th percentile instead of 1% low, and that's basically it. That's the main points of my testing. Anyways, so as you can see from the results, there are 2 games where it benefits from, but there's one game where it hurts a lot, and that's Gears of War 5.
Yeah,
I don't know exactly why this is. It is a DX12 title, which is interesting. You would expect GPU scheduling to help a lot in DX12, but it actually, in all the DX12 titles I have tested, one of them benefit, one of them hurt, and the other ones didn't budge at all. So it's API agnostic because Witcher 3 is a DX12 title. I mean, sorry, DX11, and you can also
that's probably one of the best results. In
yeah,
fact,
that's probably the best result. I've heard that it's also good in Minecraft, which is a hard benchmark, and Rise of the Tomb Raider or Shadow of the Tomb Raider, one of those two is like pretty good. I think it's Shadow. Anyways, but also like a 3D Mark where the physics performance goes down with GPU scheduling on.
You did this in your newest article. This was one that you released yesterday, yeah?
Yes.
Yeah.
This was interesting to me because I was just running this expecting it to be pretty much the same, or maybe the GPU scheduler would be better. But surprisingly, the only difference was that physics score was lower. You would expect it to be better with the GPU scheduler on because it's moving the GPU scheduling from the CPU to the GPU, but that's not the case. I have no idea why this happened.
Yeah, that's a little bit strange as well.
Yeah, it's not as severe in TimeSpy.
I wonder if one reason for the mixed results you get is depending. So each application or game that you have been benchmarked, whether it's CPU or GPU starved. So if it's CPU starved, it helps, or if it's GPU starved, it hurts.
Maybe. Yeah. I would say Forza is slightly CPU bottlenecked. Gears of War 5 is absolutely GPU bottlenecked. Grand Theft Auto 5, I actually don't know. I wasn't looking. Hitman 2 is GPU bottlenecked. That's definitely the case. Metro's GPU bottlenecked. I don't know about Total War. Witcher 3 is definitely GPU bottlenecked.
Total War really ought to be CPU bottlenecked. All those units on the screen.
Yeah, but this is like I said, this is the G14. He's using the 4900HS, which is really fast, and the GPU is comparatively slow, since it's a 2060 Max Q. So, I just can't really see a pattern in here. It doesn't have anything to do with APIs, obviously. I don't think it has anything to do with bottlenecks. Could be, but I don't think so.
It'd be nice to test it with, like, much faster cards as well.
Yeah.
Yeah, we'd be more than happy to bench it on a 2080 Ti if NVIDIA is listening.
I think
Good luck with that one.
So I think NVIDIA isn't really advertising this much because it probably doesn't do much, unfortunately. I was really excited to see the results. It could be the hit and
miss of it, too. They don't want to say, look at what it does, but then have it do what you saw there in the earlier benchmark, Gears of War 5, where it just hammers the crap out of it.
But what if this is what if this feature is a marketing feature for the 3000 series?
It might have some improvements in 3000.
Yeah, that's an interesting thing to think about.
I speculate that since this is also the driver that adds a bunch of DX12 Ultimate stuff, that we could see better support for this feature in DX12 Ultimate. But again, it's not API dependent.
Yeah, but it could still work a lot better or a lot more consistently under that.
That's true. That's true. I just think Witcher 3 is such an interesting result because it's a very old game at this point. I mean, it makes me happy since I love Witcher 3 and Hitman 2.
Yeah, that is pretty strange that it's working so well with that one.
I think that's all for this one.
Yeah. Moving on to
Apple.
Apple again, actually going back to Apple in that case.
Yeah.
So basically they've just kicked out Intel, and any one of you want to talk about it?
I mean, Kirk, Aurelian, if you don't, I will.
Go for it.
All right, so
go ahead.
They finally got rid of that tumor Intel. They're finally doing something better than Skylake 5.
Hey, based on the slides, you can't call them a tumor. It's AMD that has the tumor icon. Okay,
Anyways,
go ahead.
But yeah, did Apple even take Comet Lake? Did they ever use it? I don't think they did they?
No.
Yeah,
No.
they didn't. They didn't even take that. They did take Ice Lake though, very late though.
Yeah, with how late they've been adding these CPUs, it's on the tail end of the manufacturing process.
So yeah, they're going for ARM now, and I think going off a slight tangent here, when Linus Sebastian, Linus Tech Tips, he reviewed the recent MacBook Air, I believe it was, where like the heatsink and the fan were like really far away. He made a theory that and this was before the official announcement, but that they were going to announce ARM CPUs and they were going to reuse the same exact design and show how better it was on ARM than Intel, because Intel uses a lot of power and not very efficient anymore. And well, that could be true, seeing as they're finally transitioning. And the main reason is going to be that Intel just hasn't been making very much progress in either performance or efficiency, and efficiency is especially important.
Well, Apple's ARM CPU caught up with them, if that tells you anything.
Yeah. So I'm looking at this slide with Macs with Apple Silicon, where presumably they're comparing Intel CPUs in their...
What does this slide show? I can't... I'm looking at it as well.
It's
showing... What is this showing?
It's showing desktop performance in the power consumption of a notebook. That's what it's basically showing. They're giving like a vague like blue tile thing where like, well, this is generally where we're at right now. But basically it's saying that Apple's going to have the performance of a desktop within the package power of an Intel
right, so
CPU
yeah,
in the
right,
notebook.
now I get it. So this whole thing is a very vague sort of...
Yeah.
Right.
But that's, I mean, given that we don't have any figures...
Are they doing this with 5nm chips, do you think?
Maybe. They could be.
I mean, this would seem to be the only really likelihood that I can imagine. And are we looking at something that's maybe 200 square millimeters large on TSMC 5nm? I mean...
I'd say even smaller than that, Jim. 200 is a lot.
I would dare say it's the same chip that they're busting out for their iPads.
You think so?
I would
now,
dare venture that guess, yes.
Considering how close notebooks and desktops are in this graph, we probably have to assume that these are some really low-end desktops. Or some really high-end notebooks. But I would say probably low-end desktops.
Yeah, they're not a dual socket Mac Pro or anything like that.
Probably not even like an 8-core or something or other. We're probably talking about...
I mean, the thing here is they're going to be comparing to their own stuff, yeah?
Yeah.
Or they should be. So this must be an Intel desktop. Yeah.
Well, that's the question. Does Intel make desktops? Would Intel call their stuff a desktop? And also the same thing with the notebook. They wouldn't call their stuff notebooks, would it?
No.
So this is very, very vague.
Yeah.
Intentionally,
extremely vague. Yeah. You just can't really tell.
They're just basically promising better performance per watt.
Yeah, and the slide prior to that has the spec 2006 energy efficiency estimate, by the way.
Yeah.
That gives you some actual numbers that compares Ryzen 3950X versus Snapdragon versus the 10900K and the Apple A3 Lightning, as well as the Cortex X1. And you can kind of see the energy efficiency, which is probably part of where this blue tile black slide came from.
Is there not an efficiency number, or is it just power and performance?
Watts, energy usage in joules with performance.
Yeah, there's
the spec speed.
There's too much going on in this, this chart.
Is not...
It's floating point and integer calculations. It's not actual efficiency of the CPU in real-world micro-op workload kind of stuff.
We needed to read this before the podcast so we could figure out which one's actually the most efficient.
Yeah, I can't follow this at all.
I think the Snapdragon... Actually, no.
Snapdragon has lower points, though, and so it is...
Yeah, but it has lower power consumption. I think... No, it's going to be the Cortex that's the most efficient, I think. Okay,
anyways, has slightly better, but it uses a lot more power What
Stop trying to figure this out. This is a terrible
the
chart.
point that they're
Ian-
trying to make is that the Apple
I'm
gets
sorry, Ryan.
a high
This is
score
Ryan's doing.
without much in the way of energy costs. It obviously takes more power than the Snapdragon, but it gets a significantly higher score.
Yeah.
So the A13 is better than the Cortex A1 as far as efficiency is concerned by far. It's probably more on par with the Snapdragon, but it has higher overall performance with a little bit more power usage out of it. And obviously something like the 3950X, it's, they don't even show the spec in for it. But I'm pretty sure the A13 would get raffle stomped.
Yeah.
Just because it's,
it will as well.
16 core, 32 thread. They just won't have that ARM being able to keep up with that unless if they have something waiting in the wing where they just pull out 20 ARM CPU cores on some monster something or other.
So most of the talk on Twitter about this was, what does it mean for Intel? And as I mentioned earlier in the cast, that Apple were around about 5% of Intel's revenue, I think, in 2019. So
Total revenue?
Yeah, total
That's quite
revenue.
a bit.
It is quite a lot, but it's not something that, they're not, I don't think Intel's that worried about it, in all honesty. They're still going to sell those chips, they'll just sell them someplace else, and they probably won't get paid as well. But overall, you may be looking at a hit of 3% to the bottom line. Sorry, not the bottom line, 3% to the revenue. On the bottom line, Intel, I'm not even going to flinch at this, in all honesty.
Well, and honestly, if Apple doesn't sell as many Macs because of this, they're not going to flinch either. Because their Mac space, their desktop notebook segment, doesn't make them a whole lot of money. Most of their revenue comes from the iPhone and the App Store.
And even with that, if they don't sell as many, the money that they save from not paying Intel is still gonna, it's still gonna come out a net positive. You'd have thought. Obviously, they're putting plenty of R&D into this, but
but they are already doing that for their iPads,
for everything else,
and their iPhones. These are the same A13
And
chips.
Apple can always.
Sorry, say something, Aurelian.
No, I was just trying to throw in a joke. I was just saying that if they're in trouble, they can always sell a bit more of those $1,000 stands.
The wheels for
they can diamond encrust one of their MacBook Pros, right, and just sell that for $10,000.
Yeah, somebody would buy it.
Like the golden iPhone. Come on.
Well, anyway, this was obviously big news. I don't think it's big news for the PC. The PC's in decline, terminal decline for years anyway, and this won't. It's not going to help, but I don't think it will really change anything.
But to me, this is I would say for me this would be the more interesting let's say news. Is the fact that that somebody does desktop on ARM? Is that a signal for the future PC market? Are we going to see more ARM-based PCs in the future, or is this just this is something worth thinking of? And I don't know.
It's something I was going to talk about as well.
If Jim's interested.
Apple, being the walled garden that they are, has tight control over the apps that are released. They have to go through a vetting process, make sure that they fit the APIs and are modern, that kind of stuff, or else they just don't make it. Now, they have what they call Rosetta 2 in Big Sur, which allows them to, on install time, you can see here in this slide, convert PowerPC to x86, and in this case, x86 to ARM, it being Rosetta 2, in install time. And then dynamic translation for just-in-time compiling, so it's transparent to the user. So when you install a modern x86 app that was meant for OS 10, basically, it will, during that install, essentially recompile the binary, change it to be ARM instructions, so that it will run as a native ARM app when you go to run it the first time. And that's some pretty big technology right there.
Yeah.
That's going to make their transition pretty painless as far as long as that translation works correctly, as long as they didn't do any weird programming, which in the Windows world people tend to do. but because of the code vetting and things that Apple
Yeah.
has, they're going to be
I
more
wonder.
compatible to do
I
this.
wonder.
Windows, they're not going to be able to do that because you got everyone from Joe user like myself
Yeah.
writing code and just
Yeah.
throwing garbage onto GitHub, or
Yeah.
you have some more professional places that actually code correctly, unlike myself, and they will probably be able to translate just fine. But you throw all these different languages that have all sorts of different memory management capabilities and whatnot, some that might not translate very well, and you can just see the atrocious list of incompatibility that it would bring, and you pretty much would be just falling on your face
Yeah,
for
that's a good point.
anything but the most mainstream use.
But I'm wondering of this Rosetta thing, that is this going to be like a cesspool of a source of vulnerabilities with this translation, security vulnerabilities, I mean here. So
It
will
could,
this cause
but
headaches down the road for them?
it might actually help them too, because this is going to be translated at install time. They don't say anything about any like just on the fly running that isn't necessarily installed. So they might actually have a little bit better buffer because those apps just won't translate and they just won't run. It'd be like almost trying to run a Linux app on Windows.
I mean, you're basically talking emulation in some way. How is this Apple chip going to be good enough to run that kind of stuff fast enough?
That's why it's translated at install time. It's going to take all that processing and do it up front as part of the install process where everyone is expecting to wait anyway. And then when it runs, it doesn't have to do any emulation or translation. It's already been done.
Let it be sort of native by that point.
It would be effectively native at that point.
Yeah.
It just won't be
that is interesting.
Any optimizations specifically for ARM, unless if they put it into their Rosetta, which they could do in the background for little point releases, and maybe even put a flag saying, hey, just recompile in the background all of the apps that are already installed on this thing that were translated before with the old Rosetta. And that way they can gain more performance. I don't know.
Well, it's Apple anyway. We know they've got plenty of money. They've got world-class engineers, software and hardware, and it'll be a solved problem for them already if they're talking about it. Yeah, so I wouldn't be too concerned by it. It'll
and
just
drastically reduced amount of apps to test against. I mean, yeah, that's the thing, is they just don't have the breadth of applications that we see in the Windows environments that could potentially have problems with this. I mean, can you imagine running JBoss servers on this or something? I don't see that working too well.
Right, so moving on to the next one, and this one kind of went under the radar. It was this over at VG27 24/7. Here's the reason for why the PS5 is absolutely huge. Now, obviously, the PlayStation 5, we saw it, and there it is again. It talks about the style, whether or not we liked it, and the fact that it's a little bit like Batman and all that, in the recent podcast, I believe. Or was that on Twitter? I can't remember. But anyway, this article kind of went under the radar, and it was like one of the president of PlayStation Design, was asked, why is it so unbelievably massive? I mean, why is it such a large console? And this guy, Mark McLaurin, said, it's because it packs a lot more heat than the PlayStation 4 could even dream of. And scrolling down a little bit, it was like, why is the new product bigger and bulkier? And he just instantly said thermals. It's thermals, yeah. Little supercomputers this generation, and while the 7nm process delivers amazing heat performance for the power is very extreme. Now, I think it's fair to say that, obviously, I have been speculating on this for how long now? Is it a 150 watt machine or is it a 225 watt machine? It makes the difference between, Big Navi being amazing and Big Navi being good.
Yeah.
Or even very good. And I think now we're finally getting the answer to this, This is a 225 plus watt game console, I would say. Which sadly means that Big Navi is just going to be very good at best. It's not going to be fantastic.
I think that what this especially means that the clock speeds aren't going to be Like we were expecting that clock speeds were going to be even higher than what we're seeing on the PS5, but if the power consumption is so high, and what they were saying about dropping the clock speeds to gain a lot of power, to drop a lot of power,
Yeah.
It's got to be that the clock speeds this is probably where they end.
Yeah,
I don't think they're going to end at 2.23.
I don't think they have to.
I think they can get to 2.4.
when you put it into a desktop, you have a lot better opportunity for thermal.
Yeah.
And so you could push it above the efficiency curve and get more clock out of it, especially for some of the lower end ones that don't have as many CUs as we'll see in like an 80 CU card.
Yeah.
But what were we talking about before the podcast even started?
Well, here's the thing. I mean, I don't know why I never really analysed this properly, but in Cerny's Road to PS5 announcement, which I've covered a few times now, he actually explicitly said, and I need to actually call it up on the podcast. What was it he said? He said,
"Oh, I have it. I have the quote. To reduce power by 10%, it only takes a couple of % frequency reduction."
Yeah, so you're talking around 50 megahertz, between 50 and 100 megahertz. You drop that 2.23 gigahertz down to 2.1, 2.13, maybe even 2.15, and it's going to reduce power by 10%. So if this is a 225 watt game console, you're talking 200 watts by dropping 50 to 75 megahertz, maybe. Yeah, which means, as we discussed before the podcast, that 2.23 gigahertz, it is getting towards that edge of might not be quite on the ragged edge of the efficiency curve, but 25 watts to save, let's say it saves 20 watts of power for 50 megahertz. Yeah, I know that means that the next 150 megahertz is probably going to be 40, 50 watts on top of that, which is quite a lot.
Well, I think it kind of suggests that Sony got word that Microsoft put 52 CUs in their Xbox, and they're like, oh crap, we're way behind, and had to just crank up the GPU in order to
that's
have
exactly
a similar
what happened. Yeah, that's
teraflop.
exactly what happened. They had to hit over 10.
This is why they have Smart Shift.
Yeah.
I mean, this Smart Shift, I'm reserving my judgment on that, to be honest, until I see it.
I think Microsoft, as we were talking about, you drop a little bit of megahertz and you instantly get all this power back. They easily were able to just funnel that into 52 CUs instead of trying to just crank up the gigahertz. Yeah. And I think they also said that they weren't like speed locked, right? They had the ability to do C states.
Who said that? Oh,
Sony. Yeah.
And so I think that might be a way to help bring their power back into check as well. If they're not needing the full 2.23, then it won't run at 2.23. And I think that's for the better, because in my office, my CPU, my desktop kicks out almost 350 watt at any point in time while gaming. And and that's with an underclock on my GPU to keep the thermals in check so that my room doesn't get very hot. And it gets rather warm when it's trying to do things like handbrake and game at the same time.
Oh yeah, no question about
that.
Uncomfortably
Kirk, let me
warm.
guess.
Yeah.
Vega 56.
No, 1080 Ti.
Yeah.
Wow, really?
It's still kicking out 225 watts of power, Matthew. Yeah, out the back. I mean,
well, at least it's fast.
Well, I underclocked it and undervolted it. I've tuned it down because I needed something a little bit more comfortable in my office, but I can easily regain that performance back just by flipping a switch in MSI Afterburner.
That's why you want Radeon Chill. Cerny also said, however, during the presentation that they had to cap it at 2.23 because they said it would have gone further, but they had to draw it back in. So that still made me wonder.
Cable?
No, I really think they're talking about power at that point. Like how they didn't specify how much further. We could be talking about 2.25, 2.27.
Well, for sure it's all about power. I mean, because if they can save 20 watts of power for 50 megahertz, then the next 50 megahertz after that is going to be saving 25, 30 watts of power.
But I think what we were expecting is that what they were talking about was like clock speed mainly, that it could go to like 2.3, 2.4, and we're thinking, oh, well, they can't do that because they're power limited, because consoles don't have a lot of power. But really, in this case, it's probably that they've upped the power limit, and even that's not enough. And there's also like this thermal issue and everything.
Yeah. But it does kind of point to sadly, possibly the one that was more likely all along, in that RDNA 2, it's going to be another great, leap forward for AMD. In efficiency as well, but I still don't think they're going to be matching Ampere, at least.
No.
Especially not knowing what, I know about that.
Does that mean we have to update our mug so it doesn't say waiting on RDNA 2 anymore?
Yeah. We should do that preemptively.
Hey, now you think about it, it's sort of like perpetual merchandise for us. Yeah, I mean, so why not?
We've already burned through like 3 or 4 of them, so...
It's a challenge to see how full the mug can get.
We're probably going to have to start wrapping it around the mug rather than just putting it on one face of it. This is getting ridiculous.
Yeah.
All right. So, Jim, I think on the next topic, you'll enjoy this one. So, go ahead and lead us off.
This slide deck that I made the video on last time, honestly didn't expect it to be a very popular video at all. And neither did the person who leaked me the slide, because they'd had it for like a month and just tossed it my way and said, maybe there's something in there that you like. And I thought, yeah, actually, I can make a short video on that. Short 39-minute video.
Yeah, I was about to say.
Yeah. But for some reason, I mean, this became pretty popular. Video cards were one of the earlier ones onto it, and pointing out the slides, took slides, and also later on added my video to it. They also cited me at the top and the bottom, which is good form. We like to see that.
Yeah, great shout out to Video Card Z. We definitely appreciate everything they've done for us in this regard. This has been awesome.
Is that how you pronounce it?
Video Card Z. It's just Video Cards.
Well, I know. They replaced the S with a Z. I call it Z.
Kirk's not hip. He's not hip. He's not
Video Cards.
Video Card Z? What the hell? But anyway, one of the most interesting things about this for me was, as you know, I was like only a quarter of the way through the deck after maybe 25 minutes of the video. So I really had to rush through the second or the remaining 3/4 of the deck. So I did kind of miss stuff, or I skipped over it. But some of these guys had a bit more time to have a look at the slides a bit more closely, and they found 1 or 2 things that I had just missed a little bit. Like, for example, Intel reckons that their i7 10750H, which is going to cost less than the Ryzen 9 4900HS. That's a Zephyrus G14 versus an MSI one for the Intel CPU. We see that 20% better on average in gaming. However, they've used the NVIDIA RTX 2060 with the MSI, with their own machine. But it's an RTX 2060 Max Q for the 4900HS. Now, I did say I would maybe take these numbers with a bit of salt, but I just kind of missed this whole Max Q thing, which, of course, Matthew, you'll tell us how much slower that is compared to the normal 2060.
Yeah, I don't know exactly how much, but the Max Q was going to run about 1300, 1400 megahertz. And the mobile one, I mean, it's going to run quite a bit faster. I mean, just the G14, which I personally own, that's my daily driver, and I did a review on it. It's a really thin laptop. This MSI laptop is quite a bit thicker. Yeah. You can also see that the CPU has a higher TDP. That would indicate to me that it has a lot more cooling capacity. I mean, heck, we could probably just look up the heat sinks for these.
Yeah.
Let's. You can talk about it while I.
The thing that they have going for them is that it's a $1,300 laptop versus a $1,450 laptop. So they do have some leeway there. That, hey, look, you can get a 2060 with our CPU in it rather than only a 2060 Max Q with an AMD thing in it, and save $150 while doing so and get this better performance. Now, of course, they're saying gaming performance. instead of CPU performance, which may or may not actually be a CPU advantage on their part. But gaming performance,
they're going to lose it. They're going to lose during.
But if you can get a better GPU, you're of course going to get better frames, hands down. But have you seen?
That's how simple it was. It's a better GPU that's in it, which is why they're getting that kind of performance. Yeah.
But have you seen any announcement of a Ryzen 4000 laptop CPU being paired with anything better than 2060?
Nothing.
Exactly. It makes me wonder why. Why aren't we seeing a 2070 paired with a 4000 series? Or even
I think
a 2080?
one answer to that, Kirk, is if you just look at the prices. I mean, how do you think Intel can get a faster GPU at a lesser price? I mean, $150 more. Do you think that AMD are making more money per CPU than Intel are? Absolutely not. But then again, Intel are, they're certainly throwing a bunch of money at MSI and the rest of the guys for this, for all their Ultrabook funding and all that kind of thing. Even though these are not Ultrabooks, there's a lot of MDF.
It wouldn't be surprising to me that there might be some discounts, we'll call them.
Yeah.
The competitive advantage.
And moving on to the next slide that we had a bit of consternation over. This is a kind of funny one for me because I knew there was something off, but I'm kind of immune to marketing. Like, I don't even understand how it works on people. I know that it does work on people, but I don't understand how. And looking at this, I just sort of knew something was off, but I couldn't really narrow it down what it was.
Slide number?
Now, this is the slide number 8.
Oh.
Desktop performance positioning. I'm just looking at the video cards article right now at these. The one that's got the Ryzen 5, Ryzen 7, Ryzen 9 branding and this. I mean, have you ever seen AMD?
I wouldn't call it branding because that's not using their logo, whereas the Core series uses the Core branding logo, right?
Yeah.
They mocked up some logo that looks like a virus with these little 3 legs coming off the sides. Yeah, you could claim it's a chip, but if they had actually used like the Zen logo or the actual sticker like they did with the i7 and i5 stickers, then it would have been a little less, I guess, visual marketing.
Yeah. It just looks cheap and nasty, basically, is what they're aiming for, yeah?
Yeah, they're making you have that sensation of like a virus logo from Virus Total or something like that.
Yeah.
And
the colour is a bit kind of, I don't know what colour that is, but it's not that visually appealing either, to me at least.
Yeah, it's not the AMD red either.
No, it's not. And here's the thing, I was talking about this in a recent podcast, how AMD and all these companies want their logos, they want the products shown in a certain way, they don't want their logos squashed, they don't want things turned around or like, rotated 90 degrees or anything like that. They want it to be seen like this. And here we have Intel definitely not doing that. But the thing is, 2 things in Intel's favour here. These were not meant for end users, right? As we know. So this was supposed to be something that was kept for their partners or sophisticated people working for enterprise.
Can I say something I just noticed now? On the right side, on the performance position, blue side, don't you notice something odd regarding the alignment of the core icons with the Ryzen icons? I wonder if that's a mistake or it's again some subliminal thing.
It's most likely a subliminal thing.
Ryzen 9 is below the
Just by a
i7
touch.
while the other ones are a bit...
They purposely did that.
Not sure.
During my college days for my technical writing class, I actually did an entire presentation on this kind of crap. You know, this whole visual marketing stuff. And all of this is all intentional. It may look silly to us. It's intentional. 100%.
Oh yeah, no question about that. Absolutely no question about that. They know exactly what they're doing.
Yeah, because these are made by marketing people. They are every bit of it thought out.
And sadly, that wasn't the last one that I'd missed 1 or 2 things on. I actually quite enjoyed this next one though, even though I'd missed it. It was slide number 12, Kirk, where we saw the frequency advantage and the game scaling by core count and the game scaling by frequency. The first thing to note is the different scales. Game scaling by core count goes from 1 to 1.8, and the game scaling by frequency goes from 1 to 1.4. And if they were on the same scale, they would probably look an awful lot closer, an awful lot similar. So I did kind of miss this one. I was kind of focused on the 2.5 to the 3.5 gigahertz, which was bad enough.
If it was on the same scale, it'd actually make the core count look better.
Yeah, it would.
All of the bottom ones, all crumpled there at the bottom, those would all be similar to the one on the right, but it would also put the green and the yellow up above the right, because that all goes above 1.4, even when it hits the 6-core mark.
And if you just consider what I talked about in the video, the fact that it stops at 3.5 gigahertz is like just making this look even better.
That it starts at 2.5. I mean, it's at 2.5. They're all clustered at the same spot, which tells you it's being CPU throttled or bottlenecked right there. And as it grows from there, it starts becoming more and more unbottlenecked by the CPU. Yeah. But 3.5 being the cap, what are they doing? Running this on Atom CPUs?
Yeah. What 10th gen Intel CPU even starts at 3.5?
Yeah. I mean, we know Intel has a gigahertz advantage. They can go all the way up to 5.1 kind of stuff. So why not show it from 3.5 to 5?
Yeah, I mean, that was really what I was wondering about. But there was something else about this one. What was it again we talked about? I can't quite recall.
This is a very old benchmark.
Yeah,
very
2018. November 2018 they did this. And we tried to figure out, well, what is a 12-core CPU that they used? But it doesn't actually tell you. It doesn't say in the appendix. So we did think maybe it was an AMD CPU, like a Ryzen
3950X, like the one that they mentioned.
3950X, something like that. Yeah, but it couldn't be because it was taken so long ago. This must be a Skylake, some kind of Skylake X CPU. But it didn't actually tell us what it was. And this may also be affecting something as well.
Maybe that's why it only went up to 3.5.
Yeah. You need one of those industrial chillers to run at any higher clock speed,
Yeah, they're maybe running a 12-core, 24-thread, something or other with limited clock speed because of that.
One more thing to point out. Intel thinks that the 8700K has 8 cores at the very bottom. They have like
slide?
It's the last slide. And also, this is for a benchmark that is not in this presentation. So that's really weird. But also, they're like test. This would be like for the gaming thing, what they did with the cores and clocks, but for productivity. But they didn't include that for some reason. I have no idea why. But as you can see they tested the 8700K with 2 cores, with 4 cores, with 6 cores, and also with 8 cores.
Wow. Maybe that must have been an unreleased version.
Yeah.
I think it has been released. Isn't it called the 10700K? The 9900K? Something like that?
Something like that, yeah.
It's one of those two.
I think this little bit down here was just suffering from copy-paste syndrome,
Yeah, I would say that's exactly what it is.
Oh, yeah, and it has like a 1080. Yeah, maybe that, but it says January 2020. Who the hell knows? Nobody knows what Intel does these days.
No. They had to dredge over the course of 3 years to cherry pick all of these numbers anyway. That's the problem. Yeah. You have some of these slides comparing versus Zen 1 plus, Zen 2, and some of them that integrate Zen 3 by name so that you know that they're talking about something recent, where you then apply that mentally to the older stuff as well, which is no longer relevant. I mean, it's all just visual marketing.
And the last one I want to talk about, at least regarding Intel side of things, slide number 19. This one was shown a lot in the press as well, and this seemed to upset a lot of people. And now I already mentioned that the slide previous to this, it was actually showing the Ryzen 5 3400G with integrated graphics and up against the i3-9100F with the GTX 1050. And I said, yeah, they're going to compare these in benchmarks. But they did actually say, look, the Intel systems cost $213, AMD's $136. However, then on the next slide, we see the benchmarks. The press got upset by this, maybe because some of them were missing the full context of the slide before. However, I said this about one thing that Ryan Shrout showed before when he basically said that we had taken it out of context.
Oh, I remember that.
Yeah, on Twitter.
That's the article I wrote.
Yeah, it was. Yeah, that's correct, Matthew. But my response to that would be, well, if we're taking a slide out of context, it's because, there wasn't enough information on the slide. In this slide, yeah, you're getting all this, and the press are looking at it and they're being really upset by this comparison because they're thinking, how low can Intel go when they're comparing discrete graphics versus integrated? But, if they haven't seen this first slide, then they're lacking the context. But Intel, the reason they're lacking the context is because you haven't supplied the context. If it said prices there, then people wouldn't be getting upset by it. Again, in Intel's favour, this was not meant for end-user messaging, but still the point stands. If you're going to do a claim like this in a previous slide, you should still repeat the pricing information because it's still very valid on the benchmarks. Yeah, and then later on, they went on to compare with the same graphics card, and we saw similar kind of results again. The Intel system still won. It was cheaper. Well, according to Intel, it won. And it still ended up a bit cheaper. Nobody get really upset by this, but they have also included the price in this one for some reason. Why didn't they include the prices in this one? And yet they've done it in this one. I mean, you've got 3 sets of results in like slide 21 compared to only the 2 sets, but although there are more results, it's still, they're getting slammed for something which, if you're Intel centric or if you're a fan of Intel, then you're going to say they've been misunderstood. If you're a cynic like me, you're going to say, well, it's deliberate. However, I think I gave them a pretty, I give them the benefit of the doubt in this sort of stuff. But the rest of the tech guys have been really slamming them over this slide. And I don't know if it's because of a lack of context or something else, but in the end, it's Intel's fault. They need to make sure that the information is explicitly provided on these slides. Well, they're going to get hammered for this stuff. It's that simple.
Oh, come on. You mean the footnotes at the bottom aren't good enough? Go check out our results down in slides that don't exist or, something like that.
I was just thinking whether the very existence of this slide deck, just the fact that they had to make it for their marketing is just, I mean, we all know it's because they are having challenges on the technology side, so they are squirming around and trying to do it. So just the existence, if they would have had the products, they wouldn't have had to do this mental gymnastics with this. It's hard work to make some kind of presentation like this to try to make
the best of a bad lot.
Some kind of a, yeah, exactly.
Yeah. Well, the last slide I want to talk about was this one in 25, where I called out AMD for their nonsense at CES. I mean, I was disappointed to see people defending this stuff because this is just not right. I mean, I totally disagree that this is AMD. AMD is legit saying this. It's okay. It's not okay because it says gaming performance. They are pretending that the Ryzen 7 4800H is faster than an i7 9700K desktop. By what's that? I don't know what percent that is. But
I can do it.
Yeah, 39 divided by 26. It's not
10%.
10%.
Yes.
What? No, it's not. 39.
Yeah, it is.
20.
1.39 divided by 1.26 is it's gonna be 10% faster.
What? Right. Okay, I'll take your word for it. Right, but it's just simply not the case. Yeah, there's no way that's going to be that faster than the 9700K. Okay, it is going to be in Firestrike physics score, but I was disappointed to see people, as usual, getting upset by me calling out AMD. This is wrong. This is. And it also it just made me, feel that Intel were justified in some of this stuff. But now having a second look at it, what Intel has actually been done, now that some of the other guys in the press have had a look at these slides, this entire bloody deck is just one big misdirecting lie after another. This is all this is. And I think it's every single Intel marketing presentation that I have seen in recent times. It's just a pack of garbage. Absolute garbage. And that'll lead us on nicely to some more garbage in the final story tonight. And AMD with their 25 times 20 goal This is what happened here back in 2014, was it? Kirk, or one of you guys want to talk about it?
Kirk?
Well, back in 2014, AMD committed itself to achieve an overall 25x improvement in what they called performance efficiency by 2020. Yeah, what was it called in that email that you got, Matthew? Did they call it performance?
They called it energy efficiency.
Okay, so energy efficiency. It was translated to performance efficiency somewhere along the lines. And that might be what they said back then. Well, needless to say, after a little bit of complex math, they apparently achieved their goal on paper. You can see the little logarithmic point slide here, as well as there was another one in here. Yep, right there, showing a linear plot. Looks like Anantech actually made both of these. Ian did a really good write-up over on Anantech. So
it wasn't just Ian either, because quite a lot of the major tech press had released an article on this all at the same time, which I always find a bit suspicious.
Well, everyone got that email, right?
Everybody apart from me got that email, yeah. So
I got the email after the fact.
Got it after it. Interesting. Yeah. I mean, I don't know why I didn't get the email. I've been getting other emails from them, so it's not like they've banned me yet. I'm not in the blacklist yet, it seems, because I am getting some emails. I just didn't get this one. But when you find out the way that they've got to this 25 times power efficiency, this is, I just like face palmed when I saw it. And let me find the quote. Where were we? Quote was...
What quote? Are you talking about the one in my email, or?
No, the one. How they got to 25. Well, actually, the final was almost 32 times efficiency. Overall,
yeah, 3177. They started with the 2014 Kavari, which was a 19-watt TDP processor to begin with. That was their baseline.
19 watts was that?
Yeah, it was a 19-watt TDP CPU.
Right. And then they finished with Renoir 2020. And we can see that the difference in Cinebench scores are absolutely incredible. And it is like, what's that, 5 times higher score? That looks like more than 5 times.
Well, how they get to it is that they take this compute score divided by the energy score. So it's going to be 5.02 divided by 0.16. And that's how they get the number.
But the thing is, right, they've achieved 5.02x performance gain. Right? Performance is basically, they're talking Cinebench R15 multi-threading. So that's like these CPUs working at absolute maximum. Yeah, full tilt. Yeah. And yet with a 6.33x idle efficiency.
Yep.
Which is
not
absolute bullshit. It's two completely different things. 5% performance gain with a 6.3% idle efficiency. I mean, these things are not even linked in any way, shape, or form.
Yeah.
And yet they've combined this for this 31.77x. And they've gone to engineering and said, guys, we've really messed up with a slide 5 years ago. Help us out of this. And the engineering's, in all honesty, I don't even think engineering would do this kind of thing we're looking at here. It makes no sense. C equals 0.5 times. Is this Cinebench new? Cinebench new over Cinebench base?
Yep.
The hell.
It's like I don't know. I think they watched a lot. They watched a lot of Countdown, I bet.
It is a load of crap. They were never making it, and they figured out last year. And so now you can see like they were at 10.88 or something, and now they're saying, yeah, we've made another 3 times since that point. Absolute nonsense. And you and I were talking about it before the podcast, Matthew. And we thought that, back then when we first saw that slide, we thought, yeah, well, you're talking 28 nanometer CPU, and they might go to like 14 nanometers and maybe even 10 or 7. Back then, we were thinking, yeah, I can imagine how they can do that. I mean, Kaveri was garbage for a start.
Well, hang on. That was my first CPU, so you can't say
Okay,
that.
It wasn't garbage. It was all right.
It was nostalgic.
Yeah. And they figured out there's no way we can even get away with this slide, this 25 by 20 thing, unless we fabricate our own metric, which is what Intel and Nvidia are very good at doing. Actually.
They picked their 2 favorite things, 3D Mark and Cinebench.
Well,
here.
this is 3D. This is 3D Mark 11. This is a very
3D Mark
old one.
11P. So the physics score, right?
Yeah. Mhm.
Yeah.
That way they actually get the CPU count. But they do a 50-50 weighted average between the two score differences, right? And then for the efficiency, they test power off, sleep, long idle, short idle, and they kind of do an average on those to come out with their efficiency score that they then combine together. And I mean, long idle, short idle, sleep, for Pete's sake, none of that has anything to do with running power, like actual on and working, which is what the performance is measuring. And this is supposed to be a performance efficiency. So you would think that they'd at least run it under light workload or some silliness to even get close to a performance efficiency. But they don't. They just have an on and idle efficiency with a performance metric.
And here's a face-palmingly stupid thing about this, right? See if they just hadn't said anything and forgotten all about this 25x20 thing. Nobody else would have remembered it. Yeah? I mean, nobody else cared.
Somebody might have brought it up as a goal, and they're like, oh, I guess they just didn't hit the goal, right? It would have been a news cycle.
And now, basically, I brought attention to the fact that they haven't met a goal. I just don't see the point in that stuff at all. It's been a slow news month. Yeah, I guess maybe it's been a slow news month. And AMD do like to get something out every month. So they've clearly had very, very little worth talking about. And decided to fabricate something here, which is better off left. It's better off left at the drawing board, this one. Absolute nonsense. With that, I guess we're done with the tech part of the podcast. Are we having a question and answer, or are we just...
we have a couple of questions. One I don't think we answered yet in a podcast, which is SM_CKBK asked a question of how do you see NVIDIA in 5 years' time?
That's a good question.
Yeah.
I mean,
5 years?
They're being shoved further and further into the niche of gaming GPUs, right?
Yeah.
They've kind of floundered on their Tegra lines, so having ARM CPUs, and they've been driving hard into these other facets of compute that they could potentially move their market into, such as server-side compute, as well as like 3D vision and things for automation, like autonomous cars. And I think they've been making some good headway into those side gigs. And I think that's where I see them in 5 years, is kind of making gaming GPUs as a side effect of their compute cards.
Yeah.
And so we'll get some of the stuff that they get with those niche use cases. Because ray tracing, for instance, I could see that being beneficial with 3D vision and things like that. So those ray compute cores, the RT cores, those things are potentially very useful for those workloads.
My answer to where or what I see NVIDIA being, or where I see NVIDIA being in 5 years, is completely out of sight. I reckon they will be so far ahead of both Intel and AMD. I reckon they'll be... I mean, I hate saying stuff like, they'll be worth $1,000 or something like that, because obviously I don't want people throwing money at them, but this is just the way I see it. I think NVIDIA are going to go from strength to strength, and I think they're going to be an extremely wealthy and powerful company in 5 years' time.
Yeah.
That's what my answer would be.
I was worried about them, hearing about Big Navi.
I'm worried about them for different reasons, yeah. I don't
thinking,
want them in control of AI like they are, or they could be.
But I was thinking Intel from one side, AMD from the other. It's going to be very difficult for NVIDIA. But I don't know now. I mean, this generation, 2020, 2021, I think NVIDIA is going to be fine. I think the generation after that could pose a challenge to NVIDIA. But now I think it's a lot less likely.
I'd be more worried about the other two than I'm worried about NVIDIA.
Yeah. Aurelian, any opinion?
I think I kind of have a mix of your opinion. I think that on the PC market, I think that the APUs will go more and more common also on desktop at some point. I see that the discrete market will become niche. Discrete GPU, I mean. will be niche and probably expensive, so only for those few people who, and the masses will use APUs. So I see that maybe on the desktop, NVIDIA will be some kind of a premium, well, like it's now, but they will have a fewer offerings and very, very expensive ones and powerful and expensive ones. And I also agree that they will probably go a lot more into these dedicated domains like self-driving cars, AI, stuff like that. I mean, they have already boasted about some big deal they are doing with BMW on that. So, but I also agree with you, Jim. I think financially speaking, they will. I don't see any kind of clouds over their
No.
sky. I think they will go very well.
Yeah, for sure.
The next question, we've all had a chance to answer that one. So next question is from a user on our Discord called Yourself. And he asked about Apple moving to ARM and brought up issues about backwards compatibility, as well as the performance of ARM going forward, and even emulating x86 because they will support parallels with 86 desktop virtualization. And wanted to kind of hear our opinion of the compatibility issues, as well as whether it's worth going to the ARM CPUs, and especially when Apple's making their own chips. And we did kind of cover this a little bit earlier in the podcast. Yeah, I just wanted to re-emphasize the answer to this specifically for him. So we talked about Rosetta 2 and how it will, during install, translate x86 and the old PowerPC stuff to the new ARM instruction sets. And so the performance, I don't see that being a problem. I don't see the backwards compatibility being a big problem with the fact that they've had their whole metal and graphite and all that user interface requirements for all of the apps. The desktop emulation with Windows and stuff running through parallels, I see that as the biggest problem. And who knows, maybe they'll just have limited support on that. I don't know. We'll find out. And of course, I personally think they're just going to be reusing their same chips that they're putting in their iPads, iPhones, with the like A13 Lightning and whatnot, and just putting those into their MacBooks, desktops, whatever. Anyone else want to reiterate anything from that discussion?
One thing oh no, Aurelian, you go ahead first.
Well, okay, so I probably touched this before. I mean, I touched it on the first time we have been discussing this. I personally am hopeful that the ARM will be an alternative on the PC market. I would like to have the ARM technology on the desktop market as well, if possible. But I am aware of the many challenges ahead, so I'm not. I'm hopeful, as it would be nice to have it. Not that I'm thinking it's going to be coming soon.
Yeah.
But on the other hand, I would very much stay away from this hybrid. I would personally definitely not even consider looking into this. What Apple has to do now. I mean, they have to do it, and we know why. It makes sense that they go to this Rosetta hybrid programs that are written in x86 and PowerPC, and they will be translating them, as we discussed, on the ARM instruction set. I would stay away from that like from hell's fire. I think that this is Apple's moment of what Intel has done with the, was it Sandy Bridge and onwards, with when they went aggressive on the optimization on the CPU side, which now enabled Spectre and Meltdown and all this. So I am seeing potential side channel attacks on translated code that the guys who are doing it can't even now imagine what will come, and we will hear such maybe we will hear such discussions in a few years in the future when the researchers will find side channel attacks on it. So I would not go into that. But when it comes native and there will be native application, that's something exciting and interesting.
Well, it will be native as well. You do have that option of writing new code native on ARM with OS 11.
Yeah, but I mean when it will be only native, so you will not have applications and services running that have been translated
running on
by
OS 10, for instance. Yeah.
So the thing I wanted to say was that in the question they say I don't think ARM CPUs are powerful enough to emulate x86 in the same way how they transitioned from PowerPC to Intel, where Intel was very powerful in comparison. I think it's important to point out that not only has Apple's looked at Intel's roadmap and decided, okay, that's not good enough for us, bye. But they also probably looked at AMD's roadmap and likely thought that it wasn't good enough either. Now, we do see Van Gogh and Cezanne in the drivers for the new Apple macOS update, but that could just be AMD's giving them all their graphical stuff, and that's only like the graphics component, and that won't actually be in the final version. So them choosing AMD is not a given at this point. I don't think they've chosen AMD. And if they haven't even chosen AMD, then they're very confident in ARM.
I think the problem with AMD side of things is it's not a performance thing. And obviously, they're already providing graphics to a lot of different machines. But, if Apple were 5% of Intel's revenue, what's AMD are like, the entirety of AMD isn't even 10% of Intel's revenue. AMD simply couldn't provide Apple with enough chips, I don't think.
That's true. That's also true.
Yeah. I think that's one of the main reasons why they haven't gone with AMD, because AMD will give them cheap, but just not worth it to AMD, I guess, or Apple has looked at it and said they cannot provide the volume that we require. And I would reckon that is a big factor in all this.
I wonder how many of these cheap MacBook and iMac chips, I wonder how many of those are going to be rejects from their cell phone and iPad offerings, ones that were too inefficient because of some flaw in the production that they would have had to scrap originally, especially since they've been pushing the new bleeding edge process nodes, 7 nanometer, now 5 nanometer. I see a lot of waste that they've probably been generating that they've just been eating before, and now they have the potential to just release it as a 45 watt on a desktop.
Yeah, there is a chance of that being something like that. What the performance will be like, I'm not entirely sure, but certainly at the lower end, it should be good enough, you would think.
Well, we see a lot of people using their iPads in a desktop fashion. They put a keyboard on it with a mouse, and they utilize some of the task swapping that only now the iPhone has recently added. So I see that becoming more and more a thing.
I agree with Matthew and what he said there about they've had a look at Intel's roadmap, and it'd have been fairy tales and unicorns coming from Intel, and Apple just wouldn't have believed it. And who would believe anything from an Intel roadmap? But obviously, this is something that they've also been looking at for a very, very long time. Charlie started talking about this years ago. Yeah, Charlie, semi-accurate, saying that this is coming. And he's been saying it every year for the past 5 or 6 years, but it's here now, and it will be here by the end of the year, and I don't think they'll ever go back to x86.
You know what? To be fair to Intel, they probably didn't even have a roadmap to show at Apple.
Yeah.
Well, they couldn't have just made up some more prefixes for the Lake name.
They probably fired all their writers or something.
They probably ran out of lakes.
Yeah,
they just have made their own slide deck, like the one we saw for Apple. See if Apple would buy something like that. Something tells me. I really don't think
Tim
so.
Cook.
I'm just thinking about this.
And goes
This is why you don't need more cores, Apple. You need our high frequency CPUs that run like furnaces.
Yeah, because everyone just uses a Mac for gaming, right? Intel would be great at that.
Yeah, certainly would. Right, so are we done, or was there more questions?
Yeah, that's it.
That was it. Well,
that's it.
Thank you guys for joining us. Go ahead and hit that like, subscribe button. Leave comments, of course, and you can sign up at the Patreon as well. Get an invite to our Discord. If you guys have any questions for the podcast, we actually have a channel on the Discord that you can throw that question. Or if you want to throw in the question in the comment below, we do look at the comments quite a bit, and we can pull your question out of there as well for the next podcast. And we will see you in the next one.
Catch you later, guys.